Now we move to the exercise 3.2. First problem, write all the factors of the following numbers. Here he gave some numbers and we have to write the factors of these numbers. See, what are the factors? The number which divides the number exactly, then the number is called factor. See, if we take 36, 1 divides 36 exactly. 1 36 are 36. Okay, here next, does 2 divide 36? See, in ones place we have 2, 6. So it divides 2. So 2 into 2 ones are 2, 2 8s are 16. So 2 18s are 36. Okay. Now let's come for 3. See, here 3, if we add the digits, 6 plus 3 is 9. 9 is divisible by 3. So 36 also divisible by 3. So 3 ones are 3, 3 twos are 6. Now we take 4. See, 4 nines are 36. Okay. Now here if you observe, 2 and 3 are divisible or dividing 36 exactly. So 6 also divides 36 exactly. So 6 6 are 36. Here 5 is missing. See, in ones place we have 6. So it is not divisible by 5. Okay, here if you observe, 1 into 36 is 36 and 36 into 1 is also 36. Here order of multiplication is changed but the result is same. So here on the left side are the factors and the right side one also factors. See, here the factors of 36 are 1, 2, 3, 4, 6. Here also we have 6. So we have written 6. Next, 9, 12, 18, 36. 1, 2, 3, 4, 6, 9, 12, 18 and 36. These are the factors of 36. What we call factors? If you check 12 threes are 36. 12 divides 36 exactly. So 12 is a factor. Okay. Here these numbers are the factor. Now let's move to the 23. See here, 123s are 23. See, does it divisible by 2? No, in ones place we have 3. So it is not divisible by 2. If we check by 3, sum of digits, 3 plus 2 is 5. So it is also not divisible by 3. 4 also it is not divisible. 5 also it is not divisible. In ones place we have 3. But for the divisibility rule of 5, in ones place we should have either 5 or 0. So it is also not divisible by C. See, only 1 and 23 are divisible or will divide 23 exactly. So 23 has only 2 factors, 1 comma 23. See, as it has only 2 factors, this number is called prime number. 23 is a prime number. So it has only 2 factors. One is 1 and other is itself. So 23, 1. Okay, now let's move to the 96. See, 196 are 96. See, in ones place we have 6. So it is divisible by 2. 2 4s are 8 and 2 8s are 16. 2 into 48 is 96. Next 3. 9 plus 6 is 15. 15 is divisible by 3. So 3 3s are 9. 3 2s are 6. Okay. Now here it is divisible by 2 and 3. So it is divisible by 6 also. Okay. 6. 6 ones are 6 and 6 6 are 36. 6 into 16 is 96. Okay. Now let's check for 9. Does it divisible by 9? No, it is not divisible by 9. Now let's check for 8. See, 9 plus 6 is 15. 15 is not divisible by 9. So 96 also not divisible by 9. Okay. Now 8. See, 8 ones are 8. Here 1. 8 twos are 16. So 8 into 12. See, 8 ones are, see, 12 into 8. 8 twos are 16. 8 ones are 8. 8 plus 1, 9. So 96. Here, these are the left side one are the factors and the right side one are also factors. So now what are the factors? 1 comma 2 comma 3 comma 6 comma 8 comma 12 comma 16 comma 32 comma 48 comma 96. See, these are the factors of 96. Okay, now let's move for 115. See, 1 into 115. See, let's add in one's place we have 5, so it is not divisible by 2. Let's check for 3 divisibility. 5 plus 1 is 6, 6 plus 1 is 7. The sum of the digits is 7. So 7 is also not divisible by 3. So this number is also not divisible by 3. Now 4, it is not divisible by 4. So in one's place we have 5. So it is divisible by 5. So 5 into 5 2s are 10, 5 3s are 15. Okay, other than 5 there are no more factors for 115. See, the factors are 1 comma 5 comma 23 comma 115. These are the 4 factors of 115. Okay, what we have did, we have checked the multiples and we have written them as factors. See, here left side 1 is also factor and the right side is also factor, because 18 into 2 is 36. So 18 is also factor. Okay, by this we have found the factors of each number and we have written all the factors here. Here first one is done. Now let's move to the second problem. Which of the following pairs are co-primes? See, here he gave some pairs of numbers and he is asking which of the pairs are co-primes. See, what are co-primes first? What are co-primes? See, if two number has only one as their common factor. See, if you take 3 and 8, here in these two factors is 1 and 3, here 1 2 4 and 8. See, here if you observe the common factor is only 1. So if two numbers has only 1 as their common factor, then the numbers are called co-primes. Now here he gave some numbers and we have to find which pairs are co-primes. See, let's write the factors of 18. 1 2 3 6 9 and 18. See, for 18 the factors are 1 2 3 6 9 and 18. See, 1 18s are 18, 2 9s are 18, 3 6s are 18, 6 3s are 18, 9 2s are 18, 18 1s are 18. See, these are the factors of 18. Okay, now 35. Here factors are 1. Next in one's place we have 5, so it is 5. Next 5 7s are 35. Okay, 7 is also factor. Next 35. Okay, 5 6 7 8, the sum of digits is 8, so it is not divisible by 3 or 9. Okay, the factors of 38 is 1 5 7 and 35. Okay, here if you observe what are the common factors, here we have 1, here we have 1. There are no other factors in common, so it has both the numbers has only 1 as their common factor. So 18 and 35 are co-primes. Okay, now let's move for 216 and 215. See, factors of 216. 1 is the common factor. Next in one's place we have 6, so it is divisible by 2. Sum of the digits, 6 plus 1 is 7, 7 plus 2 is 9, 9 is divisible by 3, so 3. Okay, here 216 divided by 4, 4 5s are 20, 1 6, 4 4s are 16. See, 16 4 also divisible by 4 divides 216 equally, so 216 also divisible by 4, so 4. Next it is divisible by 2 and 3, so it is divisible by 6. Here sum of the digits is 9, so it is also divisible by 9 and 54 and 216. These are the factors of 216. Okay, now let's write the factors of 215. 1 5, next 215. Okay, here The factors of 216 and 215 are written here. The one and only common factor is 1. So these are also co-primes. So co-primes. Now let's see the factors of 30. 1, 2, 3, 6, 5, 10, 30. These are the factors of 30. Now 415. 415. 1. 4 plus 1 is 5. 5 plus 5 is 10. So it is not divisible by 2, 3. It is divisible by 5. See, here we have written 1 and 5. Here already we have 5 as factor of 30. Here also 5 is the factor of 30. So these are not co-primes. Here we have 5. Here we have 5. Here we have 1. Here we have 1. There are more than 2 common factors. But for co-primes, it should be only 1 as the common factor. But here we have 5. So these are not co-primes. Now let's move for 17. Factors of 17. 1, 17. 17 is a prime number. So 1 and 17. Now let's move for 68. So 1, see 7. Let's check for 17. Okay, 68, 17. 17 4s are 68. Okay, so it is divisible by 4 and 17 and 68. Here other than 1, 17 also have factor in common. So this is also not co-prime. Among these pairs, what are co-primes? Only 18 and 35 and 216 and 215 are only co-primes. And remaining 2 are not co-primes. Now, in the third problem, what is the greatest prime number between 1 and 20? See, he is asking for the greatest prime number between 1 and 20. See, first, what is prime number? If a number has only 2 factors, then the number is called prime number. Okay, now let's write the prime numbers between 1 and 20. See, prime numbers between 1 and 20 is 2, 3, 5, 7, 11, 13, 17 and 19. These are the prime numbers between 1 and 20. Okay, now what is the greatest number among these? 19. So 19 is the greatest number between 2 to 19. So these are the prime numbers between 1 and 20. So what is the greatest prime number? 19 is the greatest prime number. So 19 is the greatest prime number between 1 and 20. Okay. In the fourth problem, find the prime and composite numbers between 10 to 30. See here, he is asking prime numbers and composite numbers between 10 to 30. As I told you, prime numbers has only 2 factors and composite numbers has more than 2 factors. See, first let's write the numbers between 10 to 30. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, see here the numbers between 10 to 30 are 11, 12 to 29. See, we have to find the prime numbers. See, what are the prime numbers? 11, 13, 17, 19, 23, 29. These are the prime numbers between 10 to 30. See, prime numbers between 10 to 30. What are the prime numbers? 11, 13, 17, 19, 23 and 29. Okay, these are the prime numbers between 10 to 30. Now let's write the composite numbers. See, other than prime numbers, remaining all are composite numbers. See, 12, 14, 15, 16, 18, 20, 21, 22, 24, 25, 26, 27, 28. These are the composite numbers between 10 to 30. This is the solution for fourth problem. Now, in the fifth problem, the numbers 17 and 71 are prime numbers. Both these numbers have same digits 1 and 7. Find two more such pairs of prime numbers below 100. See here he gave two prime numbers. What are they? 17 and 71. Okay, 17 and 71 both are prime numbers. What is the specialty in these? Here both the prime numbers have same digit, which is 1 and 7. See here 17, reversing it became 71. 71 is also a prime number. Okay, we have to find two more such pairs below 100. Okay, we have to write two prime numbers. On reversing it also, it should be a prime number. Okay, have you understood? Here 17 and 71 both are prime numbers and it has both digits 1 and 7 are same. We have to find two more such pairs. See, if we take 13, here 13 is a prime number and reversing of it becomes 31. 31 is also prime number. See, it have 1 and 3 same digits. Both are prime numbers. So first one is done. We have to find one more. Let's take 79. 79 is a prime number. Now on reversing it becomes 97. 97 is also a prime number. In these 7 and 9 digits are common in both numbers. So these are the two pairs below 100 where two digits of the number is same. This is the solution for fifth one. In the sixth problem, write three pairs of twin primes below 20. Here we have to write three pairs of twin primes which are below 20. See, what are twin primes? Okay, if two prime numbers have difference to, see, 3 and 5. Here the difference between 3 and 5 is 2. So if two prime numbers have difference 2, then the prime numbers are called twin primes. Here he is asking for three pairs of twin primes below 20. We have to write three pairs of twin primes. So first we write what are the prime numbers below 20. See, 2, 3, 5, 7, 11, 13, 17, 19. These are the prime numbers between 1 to 20, means below 20. Okay, here we have to find the twin primes. Here if you observe, the difference between 2 and 3 is 1. So 2 and 3 are not twin primes. Here now let's take 3 and 5. 3 and 5 difference 2. So 3 and 5 is a twin prime. See here 5 and 7. 5 and 7 is difference also 2. Okay, now 7, 11. The difference is 4. So these are not twin primes. Now 11 to 13. 11 to 13 the difference is 2. So this is also twin prime. Now 13 to 17 the difference is 4. So 13, 17 are not twin primes. Now 17 to 19 the difference is, so here what are twin primes? 3, 5, 5, 7, 11, 13, 17, 19. These are the twin primes below 20. Okay, here he asked for 3. We have written 1, 2, 3, 4. We have written 4 twin primes below 20. So this is the solution for sixth problem. Here in the seventh problem, write two prime numbers whose product is 35. See, we have to write two prime numbers and their product should be 35. The given number is 35. It is divisible by 5. So 5 sevens are 35. Here if you observe, 5 and 7 both are prime numbers. So 5 into 7, product of 5, 7. 5 into 7 is 35. So what are the two prime numbers? 5 and 7. 5 and 7. Okay, are two prime numbers whose product is 35. Are prime numbers whose product is 35. Here 5 and 7 is the answer. These are the two prime numbers. Now, in the 8th problem, express 36 as the sum of two odd primes. Here, in the previous problem, we have find the two prime numbers whose product is 35. Now we have to find two numbers whose sum is 36. Okay, see, here 13 is a prime number. Okay, see, let's subtract 13 from 36. 6 minus 3 is 3. 3 minus 1 is 2. The answer is 23. See, if you observe, 23 is also prime number. So, 13 plus 23 is equals to 36. Here 13 is a prime number, 23 is a prime number. Here sum of two prime numbers is 36. Okay. So, 13 comma 23 are two odd primes whose sum is 36. Okay. What are the odd prime numbers? 13 and 23. In the 9th problem, write 7 consecutive composite numbers less than 100. See, what are consecutive composite numbers? Between two composite numbers, there should be no prime number. Then the numbers are called consecutive composite numbers. See, if we take 3 to 7, these two are prime numbers. Okay. Here, 6 is not a prime number and 9 is not a prime number. See, between numbers are 7, 8. See, here 7 is a prime number. Okay, so 6, 8, 9 are not consecutive composite numbers. So, it should be no prime number. There should be no prime number between composite numbers. So, then the numbers are called consecutive composite numbers. Okay, see, we have to write less than 100. If you take 90, 91, 92, 93, 94, 95, 96. See, these all are composite numbers and there is no prime number between 90 to 96. Okay, so these are the consecutive composite numbers. How many numbers? 1, 2, 3, 4, 5, 6, 7. So 7 consecutive composite numbers. What are they? 90, 91, 92, 93, 94, 95 and 96. Here in the 10th, express 53 as the sum of three prime numbers. See, we have to express 53 sum of three numbers 1, 2, 3. The sum of the three numbers should be equal to 53. Okay. See, let's take 13, 17, 23. See, these are the prime numbers between 10 to 30. Okay. Here 13 plus 17. 13 plus 17 is 30 plus 23. 353. See, if you observe 13 plus 17 plus 23 is equal to 53 and these three are prime numbers. So, 13, 17, 23. Okay, if you take 11, 11, 11. See, 11 plus 11 is 22. 22 plus, see, subtract 53, 22. 3 minus 2 is 1. 5 minus 2 is 3. See, 31 is also prime number. So, 31 plus 11 plus 11 is equals to 53. Here 31 is a prime number and 11 is a prime number. Okay. These three are prime numbers and here also three are prime numbers whose sum is 53. So, the prime numbers are 13, 17, 23 or 31, 11, 11. Okay. This is the solution. Here the last problem of exercise 3.2. Write two prime numbers whose difference is 10. So first we write the prime numbers 2, 3, 7, 5, 11, 13, 17, 19, 23. Okay, these are the some prime numbers. Okay, see, if you observe 3 and 23, see 3 and 23, the difference is 20. Here 3 and 13, the difference is 10. and 7, 17. Here also the difference is 10. Here 13 to 23. Here is also the difference is 10. Okay. Here 3 and 13. The difference is 10. Next 7 and 17. 7, 17 are the two prime numbers whose difference is 10. Next 13, 23. 13, 23. Here also the difference is 10. Here he asked for two prime numbers. Here we have written three set of prime numbers. 1, 2, 3. These are the set of prime numbers whose difference is 10. Okay. Here with this problem our exercise 3.2 is completed.